Hi everyone, welcome to Systems of Nonlinear Equations. In this particular lesson, we are going to be looking at some sort of nonlinear equation compared to a linear one or two nonlinear equations or graphs and comparing them and looking at, big yawn, sorry, and looking at where they intersect and sort of just describing the graphs that we see. We are going to start off very first with a parabola and a line. A parabola is this blue shaped graph. It's this one that I'm going to now highlight. And the line is obviously the red one. As we look at these, we can see that they obviously intersect in two places. We can mark those intersection points at -1, 0 and 2, 3. What we can also do is we can see that not only these lines intersect, but if we wanted to look at the actual tables of those lines, we can look at those as well, and we can see exactly where those intersection points happen as well. So you can quite clearly see, okay, if you have a table over here, we can see the table of the parabola right here, and we can see one point here at -1, 0, which I just screwed up something. I want this one to be 0. We can see that at -1, 0, there's a point there, but we can also see that same point here at -1, 0 on the line. We can also see it here with 2, 3. We can see that point on our table for the parabola as well as that same point on the table for the line. And we're done, or at least we're done with this particular graph. So you can see with a parabola and a line, we could have two answers. Essentially, we would have two solutions, meaning we have 2 points where the line can intersect the parabola. There are also situations where we might have, well, I want to keep my parabola up there, but I want to disappear my line in my table. What if we had a line that was further down? Oh, we still have two intersection points. How about this one? Oh, one intersection point, just right there at 1, 0. And then we can also see situations where there's absolutely no intersection. I am quite literally going to be giving you graphs of lines and parabolas, and you are going to identify where they generally cross. The majority of the graphs that I give you will be easy intersection points. You'll be able to sort of guesstimate them by the graph itself that is on there, and you'll say, okay, the point that they are intersecting, for example, with this one, the point they're intersecting at is at 1, 0. And you'll go on from there and you'll be like, yes, it says one intersection point. One of the big ideas that I want you to take away from all of this is the fact that if you have a parabola and you have a line, you could have three possible answers. Just like when we were dealing with special systems of linear equations, when we have two lines, say, for example, two lines like this, we could have potentially one solution being where they intersect here. We could potentially also have, let's see if I can do this really quick. We could have no solutions, and we could have potentially infinite solutions if we graphed the same line on top of each other. So we could have three different options. However, when it comes to actually two lines intersecting, so for example, maybe these two lines intersecting, there is only going to be one real possibility for their intersection point. When it comes to a parabola and a line, we could have two intersection points, 1, 2, one intersection point where it just skims the side of the parabola, or no intersection points. I hope that it made some sense, but really what I'm asking you to do is look at graphs and say, where do they intersect, or how many points of intersection there are? And looking at the graph, you should be able to see for this one, there's no lines of intersection, so there's no solution here. There is one solution here. There is two solutions here, and we should be able to guesstimate what those points are for each of those situations. We will have two more videos in this section. The next one will be a circle and a line, and the last one will be looking at a parabola and a circle, and we'll be playing around with each of those a little bit. Thank you for watching this one, and be sure to watch the next one. Bye!